Okay, another day of me away, another day of you getting to watch videos. So today we're going to look at angle of depression. Last day we did angle of elevation, so hopefully you're clear about that. And today we're doing angle of depression. Basically what the angle of depression is, so hopefully you got the sheet in front of you. If not, get someone to hand it out, and we're going to write down what the angle of depression is. The angle of depression is the angle between the horizontal and the line of sight when looking down. Whoops, sorry. When looking down, that's a very odd G there, looking down on an object. So, for example, in this triangle here, ignore the dotted line for a second. Here's the right angle down here. So the angle of elevation, so not angle of depression, but what we did last day was angle of elevation, right? And where's the angle of elevation? Hopefully you agree with me, the angle of elevation is right here. So that leaves one angle up here, and you might think, well, there's the angle of depression there, but that's not the angle of depression, I'm afraid. The angle of depression it is up here, but it's between the horizontal. Even if there's not drawn this dotted line, you have to imagine a dotted horizontal line there. And the angle of depression is between that horizontal line and the line of sight. So if someone had their eyeball right here, right in that corner in their eyeball, and they were looking down to this green angle here, the angle between their eyeball at the horizontal and the line of sight is right here. That's the angle of elevation right there. Now, what I want to do is take a look at something. First of all, I want to remind you of something. What do all the angles in a triangle add up to? All three triangles, what do they all add up to? 180, right? Okay, so let's imagine I gave you this angle of elevation. Let's make it easy numbers. Let's say that this is 40 degrees here. And I want to do two things. I want to figure out this angle here and also the angle of depression. Just want to see if we notice anything. I think we will. Now, before we do that, I need someone to figure out what's this angle, like this angle and this angle together. How much of an angle is that? I'll erase the red line, take a look at it. What's that angle right there? Anyone get it? This is a right angle right here. That whole thing is a right angle, meaning it's 90 degrees, right? All right, that's going to help us here. So stay with me. Here we go. If this is a right angle, how much is that? 90 degrees. And this is 40 degrees here, then let's start by getting this angle first. Remember, this is not the angle of depression, but let's start by getting that angle. Now, how are we going to do that? Well, we already know two angles, and we know all three angles add up to 180. So we can do 180, take away the 90, take away the 40. And you could get your calculator out and do that, whatever you want. You'll get that it is 50 degrees. So this angle here is 50 degrees. Now, I also want to find out in this, how much is this angle? This is the angle of depression. So how much is that angle? Well, remember what we just said. These two angles together, the red one, the blue one together, how much are those? Together, it's a right angle. It's 90 degrees. So if you just want to know the blue one, it's 90, take away 50, which is 40 degrees. So this angle up here is 40 degrees. Notice anything? Okay, let's try one more before we make our big assumption here. So last time I started with the right angle. I'll do that again. So we have our 90-degree angle down here. And last time I gave you also, I said pretend this was 40 degrees. Let's assume we know this angle up here this time. So let's assume that this angle, this green angle here, is 30 degrees. Now we should be able to use that 30 degrees to find both the angle of elevation, which is down here, and the angle of depression, which is up here. Which one do you want to get first? Doesn't make any difference. Let's get the angle of depression first. Okay, how are we going to do that? Well, we know that the green angle plus the blue angle is how much? 90 degrees. So if we want to get the blue angle, we would do 90, take away the 30, and we would get 60 degrees. So this angle here is 60 degrees. That's the angle of depression. Okay, now let's get the angle of elevation. That's down here. How are we going to do that? So we're looking for this angle. Well, we know two of the three angles in this triangle, and we know that all three of them add up to 180. So we can do 180, take away the 90 for the right angle, take away the 30, and what are we left with? Get those calculators out. 60 degrees. Notice anything again? Hopefully what you're noticing is that the angle of depression is equal to the angle of elevation. The angle of depression is equal to the angle of elevation. This will always be the case as long as you're not talking about questions like from outer space where the Earth isn't completely flat and you can't make a horizontal line. So basically for every question we do, it's always going to be the case. So why don't we write that down? Angle of depression is equal to the angle of elevation. That's very useful because it's often easier to find the angle of elevation than it is to find the angle of depression. Okay, in case you weren't clear, should I label it? This is the angle of depression here. Angle of depression. And this is the angle of depression here, in case you're not clear which angle we're talking about. Alright, let's do a couple questions together, and then you'll do some on your own in your workbook, which I'm sure you all brought to class. Alright, a bird sits on top of a lamppost. So we're going to draw a little picture here. And I hope by now you realize that with math pictures, this is why I became a math teacher, right? I don't have to draw anything fancy. Here's my lamppost. Here's my bird. I'm not going to draw a bird. There's a dot. That's my bird. And it's the lamppost is in the ground, so there's my ground. The angle of depression from the bird to the feet of an observer. The feet of the observer. Well, the feet of the observer are down there. So basically, whoa, it's a terrible triangle. But hopefully you get the sense. Here's the bird, B for bird. Here's the observer, O for observer. This is the lamppost. This is the ground. We end up with a right angle here. And it says the angle of depression. So often what people do is they put the angle in there. That's not the angle of depression. Remember, to get the angle of depression, you need to think of the horizontal. And then the angle of depression will be right in here. And it is 35 degrees. The distance from the bird to the observer is 25 meters. So I guess the distance along here, this is 25 meters. And what we're trying to find is how tall is the lamppost. We need to know this distance here. This is the x that we're trying to find. Okay, any ideas what you're going to do here? Well, angle of depression, we don't really want to use the angle of depression. It's not even in the triangle, right? It's outside the triangle. But from what we just learned up top, what can we very, very quickly fill in the triangle? If we have the angle of depression, we also have the angle of elevation. It's exactly the same. So you now know that this angle here is 35 degrees. Great. Now what we do is what we've been doing the last few days. We figure out if we look from this angle, this 35 degrees, what would we name the two sides that we're interested in? Well, I'm interested in this side because I want to know the length of that side, and that side is opposite. And I'm interested in this side because I know the 25, and that's the biggest side, that is the hypotenuse. So remember your SOHCAHTOA, which one of the ratios are we going to use here if we have opposite and hypotenuse? We're going to use sine. So we say sine 35 equals opposite, which is x, over hypotenuse, which is 25. I like to put it over 1 and cross multiply. So what are we multiplying? We're going 25 times sine 35 and dividing by 1. So I think I have a calculator here somewhere. 25 times sine 35. 25 times sine 35 equals, you're going to divide it by 1. Hopefully you'll realize that's not going to make any difference, but if you don't, that's fine. You get 14.34. So we know that the x distance is 14.34. Why don't we just call it 14.3? 14.3 meters. Does that seem reasonable? If it's 25 meters here, the lamppost is 14.3 meters? I think so. I think that's a good answer. So we're finished. Okay, one more. An airplane is flying at a height of 2 miles above the ground. Here's my airplane, and it's straight down to the ground. It's 2 miles. The distance along the ground from the airplane to the airport is 5 miles. That's a bit confusing, but basically what they're saying is from this point over to the airport, AP for airport, it's 5 miles. So there's the triangle. We want to know what's the angle of depression. Oh my gosh, that's terrible. I think I better do that over. Okay, angle of depression. Angle of depression, we need to draw the horizontal, and we are interested in this angle. The angle of depression from the airplane, yes, up here, to the airport. This is the angle of depression. But we're not going to actually figure out that angle because, you know, it's confusing. There's not even a triangle here. But what do we know again? We know that this angle here, the angle of depression, is exactly the same as the angle of elevation. This is the angle that we're going to try to figure out right here. Right? Because once we get this angle, we know this angle is the same as that angle. By the way, I guess we should make note of the fact this is a right angle. Okay, so which ratio are we going to use this time? If we're looking from this angle, what sides do we know? We know this one, opposite, and we know this one, adjacent. That's not the longest side. The longest side's here. This is the hypotenuse, so this is adjacent. Okay, so Katoa, which one are we using if we have opposite and adjacent? We're using tan. So tan of, we don't know the angle. So we put tan x or tan AP or tan, I'll put tan x equals opposite, which is 2 over 5. Now remember about your, I guess I should have said this in the last question. Remember that your teacher is fit and hot. So if you are finding the angle, use inverse tan, and if you have the angle, you only use tan. Alright, so in this case we're finding the angle. We're trying to figure out what is the angle. So we're going to have to use inverse tan. Tan, inverse tan, or tan to the negative 1, you don't really say that, but inverse tan of 2/5 will give us the answer. So the first thing I want to do is do 2 divided by 5 and see what that equals. So let me clear this. 2 divided by 5 equals, you get 0.4. So we know we want to get tan negative 1 of 0.4, and then I'll figure out what that equals. Tan negative 1, remember you're going to have to hit shift or inverse or second function on your calculator. Mine has a dedicated button for it right there. So tan negative 1 of 0.4 equals, and I get 21.8. 21.8. So what does that mean? That means that this angle right here is 21.8 degrees. But we didn't want that angle. We wanted the angle of depression. But it's the same. This is also 21.8 degrees. Alright, now it's time for you to practice. I hope you understand, and I hope you have a wonderful, wonderful spring break. I will see you after a nice 2 weeks holiday. Take care, everyone, and be safe.